Welcome back, Generals, to another Let's Fix Generals 0 Hour to make the best game ever. Okay. So we figured that the problem must be somewhere in the calc vis function or here in the overlap test. Well, this overlap test, I think that's more like a general purpose function. So that we probably don't want to touch. So then it probably becomes more like a case for this here. So it's probably the same issue. The top edges, they point upwards, and then this probably fails here. Yeah, that's my guess. Question is, how do we mitigate this then? Inside. We would have to. Frustum class. How did we again fix this issue in here, or mitigate it? Let's say. Otherwise, we can clean up here a little bit. This. I forgot the function name. It was this. No. Oh. This one. This one. Yeah. Get pick ray. Overlap test location. Border size and line. X-ray height scale. Height. Camera get frustum. Okay. Okay, so let's go down. Yeah. Okay, let's put a breakpoint in here. So the height is 64. XY, get height. Location is now 1070 40. And the frustum is corners. Planes. Okay, let me first check those at. So this is normal. Height 38. Get height, terrain. Okay. Location. XYZ. Okay. Frustum. Corners. Okay, so now these here are negative. I need to understand what the corners means. Corners 8. Ugh. Corners near, bottom, near, bottom, top, left, far. That's planes. Bah, what the hell is that? Ugh. Corners of the camera frustum. Generate the camera space frustum. Corners by linearly extrapolating the view plane to the near and far Z clipping planes. The camera frustum corners are defined in the following order. When looking at the frustum from the position of the camera, the near 4 corners are numbered upper left. Okay, there you go. The camera space has X going to the right, Y is up. Ah yeah, and Z is backwards. X to the right, Y is up. From the position. How about we write that down? Let's write this here. Corner 0 is upper left. Upper right. 2, 3, 4, 5, 6, 7. 4, 5, 6, 7 is near, far. Okay, upper left, upper right, left. This is lower, and this is where. Okay, upper left, upper right, lower left, lower right. And the planes, what are these guys? Planes. Frustum plane near bottom right, top left, far. Plane 1, 2, 3, 4, 5, 6 near bottom right, top left, far. Okay, with this information, it would probably be a bit easier to look at those values. No dollar. The other related comments can also be removed. Yeah, so at this angle, everything should be fine. Yeah, so the frustum now shows corners, and so the top ones were near and these are far, and so the far, this is the bottom, that was bottom, or let me see, already forgotten. frustum, so upper and then lower. Okay, so near, far, upper, lower. Okay, so frustum, planes. So this is, no, not planes, corners. So this is near, here is far, and these are the top ones, and here the bottom. Okay, yeah, so the top, they look further away, and the z is negative, yeah. Mm-hmm. Yeah. Mm-hmm. Yeah. Can save that. Yeah, so I think the problem begins if log.z is larger equal, or yeah, let's say it's larger than frustum corners 5 dot z minus, let's give it a little bit of a delta. So if it is larger than this, then let's put in here just something that we can put a breakpoint. Let's do printf. Let's say real top z is max this 6z, just in case we have a roll. Top z, top corner. Upper corner z. Okay, so this breakpoint should hit as soon as the top plane the top plane is looking upwards. Which apparently is the case now. No, we need to save. If it is smaller. Yeah, smaller. Okay, so let's see. So we move it down, and there we go. So upper corner is 12. This is 10. Height 16. 10. Is that 10? So now if we go here, it would collide. Check X, Y. Okay, but this is not yet where the issue occurs, right? The issue happens now. Maybe if the lower corner. What about the lower corner now? See, minus 460. Oh, that's upper, isn't it? Huh? Oh, I just realized. Wait. Okay, there's a mistake here. Corners. Far upper left. Upper. Is that true? This looks like lower here. This looks like upper. Did we label this wrong? It says upper left, upper right. Let me see that. Upper left, 0. Upper. VP max. VP min. Vertical. V. Vertical plane min, vertical plane max, I think. Min corner of the Z view plane. Min, max. 3 is 4, 4. Okay, I'm a bit confused. It says upper, but to me it looks like lower here. That this is lower and this is upper. Oh man. Upper left, upper right, lower left, lower right. Far planes, frustum corners are numbered from 4 to 7 in an analogous fashion. Corners 2, VP min 6, 6. Okay, so that's definitely far. Near, yeah. Corners. Max. Aha. Huh. Max X. Min Y. 3 is min Y. Min. So 6 and 7 are min. Min. And 5 and 4 are max. So it looks like this is lower, lower, and this is upper, and this is upper. VP. So 1. So this is max. Normal camera. Min max. So 0 and 1. Min max Y. 4, 5. No. It is min here. So here minimum is 2 and 6. 3 and 7. Ah, okay, now then. It's like that. Upper, upper, lower, lower. This is upper, upper, lower, lower. This is right, and this is also right. Left, left, and left. Yeah. Okay, I don't quite understand. 5. Let's do lower corner Z, lower corner Z. So that would be 6 and 7. So let's say if log Z is smaller than this, and then lower corner Z. Okay, let's do that. Okay, so let's put a breakpoint here and here. So now if we move the camera, we set this here. Okay, that does make sense. Why would the lower corner why would the lower corner be above Z first? That doesn't make sense. Okay, that I find really curious. So we do have also this VP max, VP min. Two. Does it ever go in here? Or here? Normal camera. Upper corner is minus 464. It looks weird to me here. 183 40. I find it extremely weird that this apparently is meant to be the upper corner. This is meant to be the upper corner, but this looks like the lower corner. These two here. So I wonder how that works. Why? Why does this not match what the frustum is set at? Okay, so one of these corners. One eight three. Now what happens? It collides inside. Okay. So what do we do if the frustum is looking up? I don't understand why the corners are not what we expect them to be. Clearly this is not the upper edge. It wouldn't be at minus something. X, Y, Z. X, Y, Z. Well, maybe Z is not what we expect it to be. Maybe Z is... Right, I think I'm confusing this right now with the coordinate system of the world. So Z is backwards. So I guess that's the issue, that it goes backwards. So when does it start to be backwards? Backwards. Oh man. Well, now they are all negative here. Are they world coordinates or not? I'm confused. Camera space to world space. So it is transformed to world space. So to me, this looks like the top edge, and this looks like the bottom edge. Yeah. Maybe it's because the camera is rotated around. Like if we were to take the camera and we would rotate it to this side, maybe from this angle it would look the way it says it would. So now this is the top edge and this is now the lower edge, and now it makes sense. Yeah, maybe. Why? Maybe. Okay, so basically one of the edges here is going overboard. Yeah, how do we fix this problem? I don't know. The problem is the frustum cannot collide at all its edges with the ground plane when the pitch is too low to that ground plane. We would have to frustum. Maybe do we have a way to rotate the camera or the frustum? No. We'd have to rotate the camera. Get transform. Consts. Get frustum. I don't know if there's a good way to solve this. It simply is not. It simply is not possible to get that frustum to intersect. So we would have to maybe take the camera and rotate it back so that it looks down, and then just assume that. So we take the camera and we just modify it so that it works for this test here. But like the view that the player sees is unchanged. That's proper. It's just for this test that we change things. Maybe. Frustum. I don't know how to mitigate this. I mean, it already was a major hack what we did here in this class with this here. It's also a hack. I don't like it. Is there some way we can do it? Can't we just... Vis min x, min y, min max, max y. It's max y. There's really some complicated logic here. This function, this whole thing here looks so over complicated that it has to do with this recursion and do so many checks here. Maybe this whole thing needs to be simplified. Like, I would imagine that we basically want a area around a center position. Wherever we are looking and that intersects with the terrain, that's the place where we want to show our terrain. Right? With min x max. Find out where values go out of range. Min x. To me, this looks like it's a really complicated way to compute the maximum visible area on the terrain. It somehow it does recursive calls in there. It's weird. It's similar to what we're doing here in this function with screen to world at Z, pick ray, and then at the corners. Similar to one of these functions in here, which I've forgotten. This one, get screen corner world points. So with these points, you can then determine where the bounds are. Yeah, but that also only works when this also only works when the camera is not looking upwards. The question is, why do we need why do we need to know the min max? So see, it somehow takes like the center point there. It wants to calculate the origin path, tactical view, get field of view. Half res mesh. What? What is this? Half-res mesh. Huh. I wonder if we can simplify this whole code here. It's interesting that we have access to the technical view here. Because we are not in W3D Vegas. Okay. So we could call get pick ray here. Yeah. We just need to figure out I have some idea what we could try. Yeah. So basically we only need to know an origin pos XY. We don't care about this beyond that, right? We don't need it for anything else. Yeah. So the only thing we need to do is get an origin pos where we're looking at. I think we can do that through the technical view, which has this get pick ray function, and then we use that. Maybe that would work. Yeah, in the center of the camera, essentially. Would be also a lot cheaper than this bullshit function here. So that would be technical view. The W3D view. This one. Screen. Ray start, ray end. Yeah. Okay, let's test that next session. I will take a break now. I have some idea what we can try. Yeah, we need to expose this function in view. Good. Then moving str copy back to str copy. Okay, good. I will end it here. Next session, I have some idea what we do. Yeah, let me write it down before I forget it. So, to do. Use tactical view. Get pick ray to calculate new org with new org xy with. Okay, good. Then I will end it here. I wish you a great day or night. Until next time, goodbye.